Are the denominators the same? No. Denominators, 8. What does 8 have in common with a 7? If you know your multiplication tables, your head may already jump to 56. There might be a number, a combination that's lower. Remember, you're looking for the least common multiple. But when the denominators are this close to each other in counting, most of the time you're going to have to multiply them together to find a common denominator. I can go through the line with you. 8, 16, 24. Okay, 7 won't go into 8. 7 times nothing is 16. Nothing times 7 is 24. Then we have 32. 7 times nothing is 32. 40. Nope, that won't work. 48. And finally 56. So it's way out here where we actually have 7 times 8 is 56, that it finally overlaps. That's because these pieces were so close to each other in size. At any rate, we found our common denominator. It's 56. And we're going to make two separate calculations here because these are two separate denominators. 8 times 7 is 56. 7 times 7 is 49. Pull over your whole number. 7 times 8 is 56. 8 times 5 is 40. Pull over your whole number. Now you're able to have your both fractions have the same denominator, so keep the denominator. Add the numerators. 89. 6 plus 3 is 9. We have a top-heavy fraction. That means that we can get a whole. We can use up 56 of these pieces and get one whole out of that. So 1, and the leftovers would be 33 56. Okay, if I was actually going to make a division problem, it would look like this. 89 divided by 56, that goes in one time. With 56, we're going to subtract it off and get with 3 and 3. See my 33? This small subtraction problem, I'll show you how I calculated. This subtraction problem, when I set it up in the division, is exactly what I see here. 89 is on top 56. So in my head, what I'm doing is I'm taking these and I'm subtracting from it here. I know that 56 goes into 89 once, and then I'm visualizing this part of it, this part right here, as this part. So I'm actually doing my subtraction there. That's just my own shortcut. If you like it, you can use it. If not, you can always do the division problem because that's what that means. Now this is in smaller, the numerator is smaller, so I'm going to have to go through my rules here. Are both of the numbers even? No. Do they both end in a 0 or a 5? No. Are they twin double digits? Well, 33 is, but they both have to be. If I add the digits on that, 3 plus 3 is 6. 3 will divide into 6. 5 plus 6 is 11. It won't work there, though. Will 7 divide into these evenly? No, just the 56, but it has to go into both. And the prime numbers, these would have to be divisible by one of these primes. And I don't believe it is. No. We would have to do each of these calculations. This might be a time for you to use your calculator if you want to on this part of it. So 33 divided by 13, 17 divided by 33 divided by 17. But if you practice and get used to this, you will come to learn these easier prime numbers. They're very helpful if you know them anyway.